Hello guys, this is second video in a series of videos about Spring Boot application performance. Here we're reviewing scheduled annotation, how to use it, how it's related to different threads, how to make sure we understand what's going on and that we expect what's happening. Make sure you see the previous video, and this is second one, like I said, where we'll go and struggle with figure out how all this works. This usually it's a nice source of information this side. You see, it's actually saying that fixed delay task always waits until the previous one finished, right? But we tried this fixed delay and it didn't work for us. So the question is why? And the answer is just because we use this thread. Fetch one doesn't know what's happening with this. Whatever work we do, it should be, let me just do this again. Let's call it fetch 0. Okay, I'm commenting. It's gonna be fetch 0. And then instead of creating new thread that's taking 20 seconds to execute, we will use this current thread. So we'll remove all this, you know. Yeah, we don't need this. Yeah. And right now, basically, we're in this current thread, sleeping. We don't need this. So right now, we're just doing this blocking execution and relying on the logic of this scheduler and fixed delay. So all this body will be under control of the scheduler in theory. Okay, let's test it. Let me comment this one. Actually, you see, I can just comment the scheduler itself without the method to make sure that it will not be executed. Okay, so let's run it. Again, this is taking 60 seconds to execute, and when we run it, we actually see that, you see, it's still running. And there is nothing going on because this fixed delay is 1 second. So 1 second delay task is ran once, and then it's waiting for another one to finish until the next and next. Let's investigate this performance application here to see if we see something that we don't want to see. So there is nothing specific here. You see scheduling one is a thread and it's in a sleeping state. It's just waiting until this work is gonna be done and blocking execution, right? So that's it. In this scenario, when we want to do something blockingly, and we want to execute some task. By the way, you see, it's like a new task is started after 1 minute. Just put whatever you want inside of schedule and fixed delay and it will work. Let's test something else. This is a fixed delay, right? And this is what? Fixed rate. Fixed rate. Will it work? 0, 1. So in this case, it's a fixed rate. So theoretically, the behavior should be different, right? So it will try probably to run it again and again, but that thing is still blocking anyway. So let's see what happens. Schedule 1. This is still working there. So maybe like 1 minute it's too much. Let's put 10 seconds. Let's do it again. Schedule 1. In 10 seconds it's doing. In this specific scenario I don't see anything different. Whether it's fixed rate or fixed delay, it seems it's behaving the same way. So what's the difference between fixed rate and fixed delay? And actually we can ask artificial intelligence just to make this video more fun. Yeah, so this is our Chat GPT, and what we want to ask it is what the difference between a fixed rate, what is the difference fixed rate and fixed delay in Spring Boot. We will test this to see if this ChatGPT could help us and if we can use it as a co-pilot. Okay, fixed rate and fixed delay are both used in Spring Boot for scheduling tasks. but they have slightly different meaning, right? Fixed rate is used to schedule a task to run at fixed interval of time, and fixed delay is used to schedule a task to run after fixed delay of time. In summary, fixed rate schedule a task to run at fixed interval of time while fixed blah, blah, blah. For example, if you set a fixed delay at 5 seconds and the previous execution task took 3 seconds to complete, the context execution will begin after 5 seconds. So that's exactly what we wanted to do, right, in our first scenario, because we don't want to create new tasks until one is fixed. But fixed rate is different than what I expected. For example, if you set a fixed rate for 5 seconds, the task will run every 5 seconds, even if previous execution took 10 seconds to complete. Yeah, but we couldn't prove it actually, right? Because we put fixed rate and fixed delay, and the behavior is still the same. The question is why. Okay, so thank you, Chat GPT, for help. I will go and see what's going on in our code. We discovered that fixed rate doesn't work for us. It seems to work in the same exactly way as fixed delay. And the reason is, I think, is because that's scheduled. It used this scheduling task pool, thread pool, with size of 1. Because it's a size of 1, it will work exactly the same as this one. At least this is my theory. Let's just test it. And again, I'm just going through all this as if you are doing this, or someone who is trying to figure out what's going on, and someone who is trying to Google and fetch data and make right decisions, right? So that's what I'm doing. So I'm just including all these research pieces to this video to make a point and see where stuff could be found. Okay, let's go there and put it to the config application properties, right? The size is 20. Let's say 20. Let's start this again. So what we're expecting right now, we expect this 10-second task to be run every sec without waiting, you know? So this is like a 10-second task, so it should be run bam, 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 10 times, but every second. Because right now the whole thing is blocking, right? And we have to wait 10 seconds until the next execution happens. But I hope that, okay, we hope that with this property that I put, things will be different. Like, I don't know, 5, clean, start. Okay, let's see what's happening here. This is our application, this is threads. And if we're looking, but it's using more than one. So it's taking these threads from this pool. But before we saw only scheduling one, if you remember. There was nothing else. So it's kind of using the pool from the pool of 5 threads to handle our scheduled events. Okay, let's go and check what's going on here. In there, we see this is scheduling 1 was triggered, and this is the seconds, right? But this is still not what we expected, actually, because I was expecting for this task to be run every second, not every 10 seconds. So it's still blocking. The only difference is that right now we don't use one scheduler, but we use many scheduler threads to handle this. But theoretically, even one thread could handle this because mostly it's actually like sleeping or parking. It's not CPU consumed execution. Again, not much has changed in this case. So at some point, it doesn't matter how many threads we have here in the pool, it's still working the same way. Let's put it to 1 again, just to prove that nothing will change. It will still work the same way every 10 seconds. So 88, next will be 98, same. And right now it uses only one scheduling, which is fine, which is almost always sleeping. Okay. Again, what we're trying to do here is just to find a difference in this annotation, fixed rate and fixed delay. Just a reminder. So far, whatever we do, they behave the same exact way. In these two examples that which we compare, we just put a body of the task as is, as a blocking execution of this method, without spinning any new threads. Okay. So I was wondering, maybe we have to use this configuration. Okay, let's try with something else. You see this annotation, I think it will not help us, but we'll try it anyway, just to know. So Same thing like fixed rate. If we put this here to be async, so it means that this async will use some rule, we don't know yet which one, to figure out. This way, maybe this fixed rate will do what it's supposed to do, which is to run this task every 10 seconds. And probably it will do it with this async, because my understanding is that if we put this async, it's pretty much the same as if we're doing this manually, creating new thread. It's just we're doing this manually and have to specify everything we want. But in this case, we're kind of saying that, okay, wrap it in a thread and connect it to the thread pool, and run it properly. Let's see. All right, let's see. So what we get? 67. So we're still waiting for 10 seconds. Nothing has changed, right? 10 seconds, 10 seconds. So this I think didn't work basically for fixed rate. I guess it's not obvious for many of you because we forgot to put this. Let's do it again. We have to enable it, otherwise it's not telling. Yeah, right now this task 1, task 2, task 3 runs every second as I expected, right? So this is how it works. But it doesn't mean that this fixed rate helped. It just this fixed rate were able to do its job because that thing, that body is not it's not blocking anymore. It's not running in a blocking thread anymore. Okay, that's it for this video. We'll see you in the next one.